We're going to take a look at this linear function. You and your partner are going to do problems 1 and 2. We have function f of x equals 2x plus 5. And what you're going to do is explain how it's changing from 1 to 2 or from 19 to 20. Just two things that are next to each other, just increasing my interval by 1. Okay? Then it's going to show you on number 2 an expression that models that using our function. And it wants you to compare what that gives you compared to what you found with the number 1. I just want everybody to do 1 and 2 to start. So, on number 1, you're going to explain how things are changing from 1 to 2 or 19 to 20. And you're going to say how you know. And then number 2, you're going to evaluate that expression that represents that change and see how it compares to number 1. So, taking a look at question number 1, who can explain how it is changing and how they know it's changing by that? How is it changing and how do you know? Riley, how's it changing? Adding 2. So I'm just going to write 2. How'd you know that?
Because when x from 1 goes up 2.
So you went from like this point to this point, you saw up 2?
Yeah.
Okay. Yeah. So that is one way we know. And then we can't see 1920, but we can imagine from here to here up 2 over 1. What's another word for that? Slope. And that repeated addition is, we can also see it right there. 2, right? We found the difference, right? We did something like, you could also look at like this point's 0.5 and this point's 1.7. Well, that 7 minus 5 gives us the 2, correct? We guys seeing that? Or is everybody seeing that? Okay. So, let's make sense of this expression. Like, you can't just solve the expression, but what this expression is saying is, if this any point works here, right? There's an x in there, so any point works. So this is my first point. Just like up here, I took my first point away from my second point. Well, the second point is always going to be 1 more than my first. So if my first point is just x, what's my second point?
1x.
X plus 1. 1 more than x, right? 1x would be 1 times x.
Right, 1x actually.
That's, so right here, again, x is my first point. That's why it's just in my function. 1 more would be x plus 1. So you can make sense of that. Let's say I'm referencing point 5. If I put 5 in here, that means I'm putting in 6. And like, so do we make sense of this expression before we solve it? Everybody seeing that before we solve it? Because otherwise you just solve an expression. So if I distribute, I get 2x plus 2 plus 5 minus 2x minus 5. And we may notice my 2x's cancel and my 5's cancel and leaves me with 2. And of course that makes sense. Doesn't matter, any 2 points that we pick, any 2 consecutive points are always going to have a difference of 2 forever because it is linear. So it makes sense. Like, so not only do we have the algebraic expression making it make sense, we found it with points, we found it in the equation. So here's what you're going to do next. You're going to look at what happens if my x increases by 4. How is that going to change my outputs? All right? And then for this, for b, you're going to make a connection right here. That's going to be similar. They're going to baby step you less, though, okay? So, instead of looking at changes of 1, now we're going to look at changes of 4 and see what happens. So, we already talked. With intuition, we know that if we go change by 4, we go up 8. Right? Change by 4 is up 8. And you can see a reasoning with here. Or you could say something like up to 4 times is up 8. We're all good on that? Now B, the expression was a little different than the original. I'm still going to take away my 2x plus 5. That's going to be what I subtract. But my second point is not just 1 more than the original. My second point is how many more?
4.
4 more. So my point needs to be 2 times x plus 4 minus 2 times x plus 5. So that's going to give me 2x plus 8 minus 2x plus 5. What did I do here? Something's not right. 2x. Oh, I forgot my plus 5 right here, y'all. I forgot my plus 5. Okay, so 2x plus 8 plus 5 minus 2x minus 5 when I distribute here. Okay? Look what cancels. My 2x's cancel. My 5's cancel. Look what I'm left with.
8.
It still holds true. Because no matter where I'm at on this graph forever, because of the slope of 2, if I'm 4 away, it changes by 8. No matter what 2 points I choose, that's what this means. No matter what 2 points I choose. Because if I slap a 5 in for x, 4 more than that is 9. If I slap a 12 in for x, 4 more than that is 16. This works for everything. For 4 or more. All right. As you can imagine in this unit, if we checked out what happens with the line, we're going to check out how it works next with an exponential function. So you and your partner is going to go after 1 through 4 on this one because we've seen a similar thing with the line. I'm going to say be cautious. Well, yeah, you guys can do 1 through 4. Make sure, just know 3 and 4 might be a little challenge, but get something. I had a good time going around seeing everybody's stuff. Some of us skimped on the explain thing, but then I think I got us going. So, everybody, how's it changing as it progresses?
3.
Yeah, by a factor of 3. And Vinny said he did 81 divided by 27 to get there. I think that's cool.
Yep.
Actually, any second number divided by the first will get us 3. Also, here's another place we can look. See that growth factor of 3?
I didn't see that.
Yeah. That growth factor also tells us times 3 times 3 times 3. So last time we had repeated addition, which resulted in a 2x. This time we have repeated multiplication that makes our exponent, right? That's the difference. Now, on problem number 2, I chose these two numbers just to try to trigger a kid, okay? 10 and 11 are what I'm choosing to be my inputs.
No.
Yeah, baby.
No.
I know. I don't like it either. I'm working on it too. So 59,049. Ooh, this is gross. 8, 10, 11. And then 3 to the 11th.
So you count.
I got 177,000.
You would have put 1 and 2 there. That would have been better.
147. Okay, regardless what we put in there, if we take the second number and we divide it by the number that preceded it by 1, we get thrizzle. 3. Every time. Because as I increase x by 1, no matter what forever, the second one will be 3 times greater. Correct?
Yes.
Okay. Now, let's complete the table. Cam's going to help me. I saw Cam. So this x, what does that pump out in my function, the x?
3x
Well, 3 to the x. Be careful, because 3x means 3 times x, but I knew what you meant. And then x plus 1, 3 to the x plus 1 would be that expression. Okay. So,
Oh, I got that.
check. We did that. Look at the change in outputs. Does it still agree with our earlier findings? So our 2 outputs we actually did up here, right? Now, let's test out this 3. What operation did I do up here to justify it and up here?
Division.
Division. So let's do it. Let's take the second one, 3 to the x plus 1, and divide by the first one, 3 to the x. And in theory, the next one should always result in triple. So I'm going to divide these. Do you remember the trick that I'm going to use here? Not a trick, but how do I get this upstairs?
You just
It becomes a negative x.
It becomes a negative exponent, right?
yeah, and then those.
So now when I have the same base, I can add my exponents. Remember, back to our exponent properties. And I would get 3 to the 1, which is 3. Because all this says is 1 after divided by 1 before equals 3. And we already found that's true for all the numbers. Again, let me say that again. This means 1 after divided by 1 before always gives me 3. And you can always test it out by substituting a number in for x. Let's say I substitute in the number 4 for x. Okay? That'd be a 3 to the 4th in the denominator and a 3 to the 5th in the numerator, right? How many more factors of 3 is upstairs? 1. That is 3. No matter what you put, so the x just means everything works, all right? Now, just like the addition or the slope, we're going to look at 3 higher this time. So you're going to do 5 and 6 with your partner. Use your table. And you're going to see how it changes by jumping up an interval of 3 with our exponential function. So let's start. Let's do Zeph's. Zeph said 3 to the 0 is 3, and 3 more than that is 3 cubed, which is 27. I lied about this 3 to the 0. That's 1. Okay, and 27 divided by 1 means 27. So if I go 3 ahead, it's a factor of 27. And that makes sense because 3 times 3 times 3 is 3 cubed, or 27. So anytime I go 3 ahead, it's going to be a times 27. All right? So right down here, I've got a 3 to the x and a 3 to the x plus 3. We good with that?
Yes.
So that just means I have 1 point and then a point that's 3 ahead. So to find that multiplier of 27, I'm going to do 3 to the x plus 3 divided by 3 to the x. Is everybody good with this? This should pump out 27. Let's test it out. I'm going to get that upstairs by using my negative exponent. And what does that give me? 3 cubed, which is? Which further proves that no matter where you're at on this function forever, if you have 1 point and you go 3 ahead, the 3 ahead is always going to be a multiple of 27. That's it, friends.